Hello everyone, welcome to bi-weekly summaries of KenteCode AI Academy by the Ambassador. We learned about API and data analysis, where we'll be discussing how to get API and manipulate it to get our data and analyze them. We'll also learn about regular expressions and Matplotlib. An API is an application programming interface that allows different software applications to communicate with each other. In data science and programming, APIs are often used to access data from web services. So we can use API to get weather data, stock prices, or information from social media platforms. We can also use APIs to access up-to-date data from the internet, automate data collection, and integrate different services into our applications. API have methods, and their methods include get, which is used to retrieve data from the server; post, send new data to the server; put is used to update existing data on the servers; and delete to remove data from the server. An example is we have import request. We are using the weather API to retrieve and display data. So we import request. Request is a Python library that allows us to use the API. So we have the URL that tells us about the Open Meteo Free Weather API, and the parameter is the data that exists in the API that we want to access. So we use the request.get method to pass the URL argument and then the parameter argument. Then we check response.status code equals 200. That means if the status code is successful, then we store the response in a JSON format where we get the data. Else we will print failed request with status code, and then we get the response status code, which will be either 404 or any other error code. So the current weather data for New York City, which is the latitude and longitude, the output gives this output. We have regular expressions. Regular expressions are patterns used to match sequences of characters in a text. They are powerful tools for searching, extracting, and manipulating text data. We use regular expressions to find specific patterns in text, validate input, and replace or split text based on patterns. So if we have a huge data set or a huge string where we want to find a particular text in that bulky text, we use regular expressions. So for regular expressions, it exists on the Python library re. So we say import re, which is regular expressions. We have text, which is a string where we have my email is test@example.com. We use .search, which is a method that exists in the regular expressions library to search for a pattern which represents an email for the text. So the pattern and then the text that we want to find. And then if we find a match using this pattern, then we print found email test@example.com. If we want to find all matches, for example, we have a list of emails, we use the method of find all to find that email. The same example goes to if we have a different example. This returns the found values in an array, so we can use the index, the brackets notation to access each of these arrays. So numbers square bracket 0 will access the first index, and then number square bracket 1 will access the second index. Matplotlib. Matplotlib is a powerful Python library for creating static, animated, and interactive visualizations. It is widely used for data visualization in Python and integrates well with pandas and NumPy. So we'll be using the past lectures with NumPy's Python. We'll be using Matplotlib to visualize the data that will be generated from pandas and NumPy. So a Matplotlib is a 2D plotting library for Python. We create visualizations which includes line plots, scatter plots, bar charts, histograms, and more. It is highly customizable and works well in Jupyter notebooks. For example, we can plot line plot. Where we have a data for a line plot, we import numpy, where we have numpy.line space, which will give us a random number between 0 and 10, and then 100. So we get the value for x. We get the numpy.sin x. We get a value for sin x. Then we print the generated data, which is x and y for the data. Now we want to create the line plot. For us to create the line plot, we have plot.figure. Plot.figure.plot.title, x label, y label, legend, grade, show. They are all methods that exist in the Matplotlib library. So for us to show the visualization, we have to have .figure. This method is the box that will describe the visualization. So we have fixed size, which is the parameter, the arguments that will be given into the figure method. So 84 is the value that will be determine the square size of the figure. So the plot is the data. Will determine what kind of data we want to plot. So x will plot the numpy line space for the value x, y the sign value of x, and then label will give us a name that would be shown on the visualization. So the following will be the results. So we have the line plot example, the sign of x, which is the y values, and then the values of x from 0 to 10. That is what we have here, from 0 to 10. So y label is sign x. That is used to show the legend. So if we have a label here, we can use .legend, which will show the legend for the line plot example. So we have .title, which will tells us the title we have to use. The x label, that is the label for the x, that is the values of x. What name does it have? Y label, also what name do we want to give to the y axis? So grade will show either the grid lines. True will show the grid lines, or it wouldn't show the grid lines when it's false. And then .show is very important because it tells us in quotes, print the figure that we have given. So if we have a visualization where we don't have plt.show, our output wouldn't be seen. So anytime we have a visualization in Matplotlib, we have to have plt.show function that will display the generated data. Another example is we can use bar plots. Bar plots, so we have a data which is an array of data, a list of data, apple, banana, cherry, mango, and the count is 10, 24, 36, and 18. So we have the figure which will describe the area that we want to show our visualization, and bar represents the bar plot which we want to plot, and the data is saying we want to plot foods and then count, and then the color argument helps us to change the color of the bar plots that we will be describing. So the output is bar plot, so the color sky blue we see here, and the x values is the fruits, which have apple, banana, cherry, and mango, as we see here, fruits, and the count is the y values from 0 to 35. So we have count 10, 24, 36, and 18. So the highest value is 36. So count is going to start from 0 through to 36. That's the highest number. And the title is the title for the plot. The x label is the label for the x values, which is fruit. Y label is the label for the y values, which is count. And then lastly we have plt.show, which will then display the entire visualization that we have. Thank you for joining this session for the bi-weekly lessons with KenteCode AI by the ambassador Emmanuel Kwash. Thank you very much.